Okay, for today's video, what I want to do is take a look at the 11-1 homework, which Alaha was kind enough to upload, which some of you, should have already done. So the first question is a basic T-test, asking about significance level, okay? So if we just enter into the calculator, now it says find the t-score, p-value, degrees of freedom only. So we are going to go to stat tests, T-test, and we're dealing with data. We're dealing with stats. So the null mean is 41.3. The mean from our sample is 44.1. The standard deviation from our sample is 9.6, and our sample size is 20. Okay. Is there evidence to support the city council's assertion, which was the city council believes the head of households are currently older than 41.3 years, so that would be a greater than question. We would calculate, and what that gives us is this over here, a t-score of 1.304, a p-value of 0.104, and the degrees of freedom is n-1 or 19. Okay? So our conclusion at the 5% significance level, since our p-value is greater than that, and we have to link it, since the p-value of 0.104 is greater than the significance level of 0.05, we fail to reject the null hypothesis. There is not sufficient evidence to support the city council's assertion that the mean age of heads of households is greater than 41.3 years. Now, just a couple of notes. The random sample is only 20. We didn't talk about the assumptions, but in this one we would have a difficult time because the sample size of 20 is not large enough, and we do not have any indication that the population comes from a normal population. Okay, so if we look at question 2, we're doing a hypothesis test. So the chief operating officer believes the actual sales revenue is less than 0.73 million. So our null hypothesis is that the mean is equal to 0.73. The mean sales revenue is $0.73 million. Our alternative would be what we're trying to prove, which is that it's less than 0.73. So that's our H. Our assumptions are random sampling. A random sample is stated. Okay, and that the sampling distribution is normal, and we want to kind of lead off each time with that. Distribution is normal. And there are three possibilities. In this case, it's because the sample size of 40 is large enough to invoke the central limit theorem. Okay, that's our A. So we have our H and our A. Our mechanics we do in the calculator. Okay, so tests, we're doing a t-test. Our null mean is 0.73. Our sample mean is 0.68 with a standard deviation of 0.02. Sample size is 40. And our alternative hypothesis, I'm sorry, we couldn't see that. That's what we have. Our alternative hypothesis is less than, bing, oops. And we calculate, okay? Oops, I had the wrong alternative, and that happens. You would have seen that it was, since I put in greater than rather than less than, our probability was 1. Here it's 0. And the reason that it's 0 is because our p-value, our t-value is so large. So our t is negative 15.81. Trying to write around this contraption I created. Our p-value is 0, and our degrees of freedom is 40 minus 1, or 39. Now, it's usually included in the assumptions, but we can state it in the mechanics. And that's really all you need for mechanics, are those numbers. We should state that we are conducting a one-sample t-test. The rubric usually says the test is identified by name or by formula. So by doing it by name, there we go. And then that leaves us free to just use the calculator output for our mechanics. Makes it pretty easy. Since the p-value of 0, right, it's not exactly 0, but it's smaller than the calculator can handle. It's smaller than 9.9 times 10 to the 99th, or smaller than 1 divided by Google. Since the p-value of 0, now we're not given a level of significance in this problem, is smaller than any commonly used level of significance. Now, we reject the null and conclude that we're going to conclude that the alternative is true. So basically we're writing the alternative hypothesis that the means that conclude that there is sufficient evidence to show that the mean sales revenue, now you could also include monthly sales revenue of the offices, but I think this would suffice, is less than $0.73 million. Make sure you include that million because you don't want to make them think that you're saying it's less than 73 cents. All right. In number 3, results of a study that claims the average amount of time high school students watch television per week. Okay, now this is probably an old question because you guys are like, you know, it's 2020 and you guys don't watch TV. Is 15.6 hours. Large high school conducts a simple random sample of 15 of its students. Assuming the population of hours is normal, test the claim. So we want to do a full hypothesis test here. Okay, so we have our context written out. I'm going to get a new sheet of paper. okay? So our null is that the mean is equal to, now they give us the 15.6 as the mean. Sample is 15, and from the sample you get 14.3 and 2.5. Okay? And what we're trying to test in our alternative, test the claim that the number of television watched per week is less than 15.6 hours, so we know what our alternative should be. So the mean is equal to 15.6, and the alternative is less than 15.6. And we want to do our hypothesis in symbols and in words. The mean number, there's something on my phone. Close. Number of hours of television watched by high school students, I should have left a space, is 15.6 hours. And then our alternative would be the mean number of hours of television watched by high school students is less than 15.6 hours. Okay, you would, that's our H. You would pay a little more attention to that. See that might have been off the screen. So our null is equal to 15.6. Our alternative is less than. Our assumptions, we're going to do a one sample t-test. Okay, so random sample conducts a simple random sample, stated. Simple random sample. And I just want to go over this assumptions piece because that's something that is easy to not, to miss like a piece on and not get full credit. And the sampling distribution is normal. Again, we want to start off with that phrase is normal because we assume the population is normal, and that's in the text. Okay? It says assuming the population of hours watched is normal. So that takes care of our assumptions piece. Our mechanics, once we've identified the test by name, now we just need to go and do the mechanics. Stat, tests, t-test again, we're dealing with data. We're dealing with stats. 15.6 cabin fever I'm getting here. 14.3 is from the sample with a standard deviation of 2.5, sample size is 15, and less than is our alternative hypothesis. So our mechanics would be t is equal to negative 2.01, p is equal to 0.0318, that's interesting, and the degrees of freedom is 15 minus 1 or 14. That, very simply, from the calculator, right? Let me just do that again in case we didn't see that so well, right? We're gonna go to stat tests, t-test, and then we enter the information from the problem. Our alternative is less than, and then we calculate. And basically, you do have to, it doesn't give you the degrees of freedom, you have to calculate that as n minus 1, but you have the t, you have the p, you're good to go. And now we have a choice. We're not given a level of alpha in the problem. So if alpha is 0.05, p is less than that, we're going to reject. If we had an alpha of 0.02, p is greater than that, we would fail to reject. So you could do it either way. And both would be correct. I'm going to reject because, I don't know, it's just a little bit more fun. So since the p-value, I would say, just as a standard, kind of use 0.05 as if they don't give you one. 0.031 is less than a 5% significance level, or an alpha of 0.05. We reject the null hypothesis. There is sufficient evidence to conclude. Now, what does our alternative hypothesis say? The mean number of hours TV watched by high school students is less than 15.6 hours. The mean, I think my daughter wants snack. Do you want snack, Tori? Yes, I'll get snack for you in a few minutes.
What are you doing?
I'm making a video for my students since we're not in school this week.
Are you talking to somebody?
I'm recording it on my phone. How about that? And they're seeing the work that I'm doing. You might be doing that next week. By high school students is less than 15.6 hours. Now, if you wanted to get fancy, you could say that it does support the claim of the student council president or something like that. Okay, and that's our conclusion in context. Boom, HAM-CC, 4 steps, done. That answers number 3. Now, I think the next couple of questions are a little bit easier. So number 4 is a residual question. And we have to remember the residual is the observed minus the predicted, y minus y hat. So we know that y in this problem is given as 100 because we're given the point, right? X is 10, y is 100. To get y hat, we would substitute into the equation 13.6. Our value of x is given as 10, the point that we're given, minus 40.5, which is 90.1, right? I'll just verify that on the calculator. 13.6 times 10 minus 40.5, 95.5. What did I do? 136, oh, 40.5. 95.5, my bad. Okay, so our residual in this case is going to be our actual value of 100 minus our predicted value of 95.5, which is a difference of positive 4.5. This is really important that you get the order correct because on a multiple choice question, we've said before, one of the incorrect choices will definitely be negative 4.5, definitely. Okay, now type 1, type 2 error. We're going to set up our table. Right, I'm gonna just do a couple spaces. Okay, so our null is true, our null is false, we reject, and we fail to reject. Okay, null is true and reject, that's type 1. Fail to reject is type 2 when it's false. Okay, so if the null is true, the burgers don't have much fat. And if we reject that null, okay, and we're disproving the restaurant's claim, so basically our alternative would be that the mean is more than 10 grams of fat, we'd have too much fat. Okay? So if we reject the null and we think there's too much fat, we're gonna change the burger, right? In order to be within nutritional guidelines. If we fail to reject, the burger's gonna be okay. Now, in this case, we change the burger, but there's not too much fat. We've changed, so for type 1, I'll write this out kind of in a sentence, we may change the burgers when we didn't need to. And for type 2, failing to reject, we think the burger's okay, but in actuality, there's too much fat, okay? We leave the burgers alone. But they have too much fat in reality. Now you could elaborate on that and say that would lead to some sort of health complications or something, right? So what you really want to do is set up the chart, okay? What is happening if the null is true? What's happening if the null is false? what's happening when we reject, what's happening when we fail to. I'm going to do number 6. I'm going to do this kind of quickly because I think my battery's about to run out. You know, I want to be in touch with the world as much as possible these days. So question 6 is, this is a geometric probability. Okay, the problem states that he has to take his road test. And it's a probability of 0.7 of passing each test. But his probability of passing neither improves nor gets worse. So every single time he takes the test, he has a probability of 0.7 of passing it. So the probability that he'll pass it on his first attempt is 0.7. The probability that he'll pass it on his second attempt means he has to fail the first time, which is 0.3, and then he'll pass. The probability to pass it on his third time is that he fails twice and then he passes. And again, the important thing is here the probabilities don't change. So that's 0.147. No. That would be 0.3 times 0.3 times 0.7, which is 0.063. And then the fourth, which is the last one they ask for, and this would just continue indefinitely. 0.3, he's going to have to fail it 3 times, so we'll use the exponent. Basically, it's n minus 1, 0.3 to the third, and then he finally passes. Okay, so that would be 0.3 to the third times 0.7, which is 0.0189. Okay. And then the probability, this is basically an infinite probability because there's always the possibility that he's going to just keep failing until these probabilities get really, really close to 0. But that's what's going to happen. There is, and we can go over at some point, there is a geometric on the calculator. What I'm going to do on, what I want you to do is, if you didn't hand it in, it's probably still at school if you did, type, I'm going to put the assignment up, type in an answer for number 7, okay? I want to see that in writing. And then we'll go over on Monday, I'll post a video about homework 11-2. And we'll go over, we'll know more information about what's happening long-term, and we'll go over 2 sample intervals, which is the same as the 2 sample, maybe we'll go over 2 sample tests again, and then I'll also talk about 2 sample intervals. Okay. Anyway, so I spent time, and I think it worked out reasonably well. I built this kind of little Lego structure to hold my phone because I didn't know what else to do. And yeah, here I am. I'm wearing the same shirt as yesterday. Sorry about that, but you know, haven't been out of the house all week, and so hopefully you're all keeping sane. I'm just turned the phone around because I couldn't flip it in mid-video. So stay safe, stay healthy. Hope to see you soon. But not sooner than we need to. So, okay. And talk to your friends. If they haven't been on the Google Classroom account, and only about half the people have, remind them that there's stuff up there to keep you going. Obviously, the AP is going to have to do something because the several states, I think Massachusetts, Maryland, and Ohio have closed schools. I'm sure there's school closings in Washington State and California, Bergen County, New Jersey. So all of those students are going to be affected, as well as international students. So they're going to have to make some decisions as to what's going to happen in May. So we're going to just keep going forward like May, whatever the date is, 15th or 16th is going to happen for us. And hopefully things will pass and we'll be back to school sooner rather than later. We were ahead of schedule. I'm going to try to keep us close to on schedule, but I need you guys to be working from home. So again, stay healthy, wash your hands. Hope to see you soon. Have a good weekend.